Hello and welcome to another Leetcode video. So today we're looking at the problem valid word abbreviation. So this is a meta tag problem that technically is an easy, but it has a lot of edge cases we have to consider, and these kind of problems are always really good to practice and understand. So basically this question reads is that we're given two strings, right? So we're given a word, and this is a full word. You can see here internationalization. We're also given an abbreviation of that word. And we'll go into the rules of abbreviation in a second, but essentially what we want to do is see if this is a valid abbreviation of the word that we were given. So the rules of abbreviation are as follows. So we could essentially take any substring here and represent it as the number of characters. So you see here for the word substitution, we're taking the S, but the next 10 characters we're actually just representing as this 10 to tell us that there's 10 characters there, and then finally this N here. So this would be an example of a valid substitution. Similar case here, but it's two substitutions, one of length 4, one of length 4 here. Also, the substitution 12, this is just the number 12, which substitutes the entire word. So you kind of get the idea. Some non-valid substitutions are as follows. So here we see 5, 5. And technically, from the problem, this expects it to be two substrings of 5 abbreviated. But whenever we see adjacent numbers like this, we treat this as one string. So instead of 5 and 5, this would be treated as 55, right? So whenever we see adjacent digits, those are going to be treated as one large number and not two distinct numbers. So just remember that. Also, we cannot have leading zeros here, right? So you'll say, we can't parse this out as just 10 because we know that valid substitution strings cannot have leading zero. So if we ever see a leading zero, we know that that's not valid. Also, we can't just replace an empty substring and do nothing with it. So this value here will be guaranteed to be at least 1. So given those rules, let's hop into an example and see exactly how we can solve this. So what we can do is kind of use a two-pointer approach here. So we're going to have an index pointing to our word as well as to our abbreviation. And there's a couple of cases that we want to handle, right? So what we want to do is, one, if we ever see that the character in the word and the character in our abbreviation are the same, we just increment both, right? Because we know that there's not really anything to consider here. We see it's the same. There's nothing really, no logic we have to go through. So we just move both up. So in this case, we would move both to index 1. So here is the interesting part. So now we see that these are not the same. So what do we do here? So if they're not the same, either one is a number. So if this is a number, so let's say not same, and we'll say A. If abbreviation is a number, what we want to do here is we want to parse this whole number, and then we know that we can use that number as an abbreviation of this word. So what we do is we parse the number, and then what we do is we move our word index by that number. So what does that mean in this case? So if we see a 12 here, right, we parse this whole thing and we say, okay, so we can use this 12 to abbreviate 12 characters in internationalization. So if we're at index 1, we could say, okay, so we see a 12, let's move from 1 to index 13, which is this I right here. So essentially what we would do is after this whole operation, our abbreviation index would be at this I, and because we've abbreviated 12 characters in internationalization, we also end up at this I here. So let's continue going through. We see that I equals I, this is the same, so we move both up. We see Z and Z are the same, we move both up. So now we are at this T, and we are at this 4. Sorry, we're actually at this A, not the T. So we're at T. We see that these are not the same, and this is a number. So in this case, what we could do is we could say we're going to abbreviate 4 characters. So we would move this up to our N here from our A, and we'd also move this up. And then finally, we see N equals to N, so we increment both. So now at this point, what happens is our word index is at the end of our entire word, as is our abbreviation index. So if we reach this case where both indexes are past the point of both the word and the abbreviation, we know that this is a valid abbreviation, right? So this is our happy case. So let's look at some cases where this would not work out. So this is very similar to our last case, but I've just added an extra n at the end here. So we'll go through our same logic and we see, okay, we're going to see the same character here, so we're going to increment them. So this comes up to this final n, but at this point, we've moved past. So if at any point one of the indexes moves past the end, but the other one is still there, we know that this is false because we have extra characters that have to be represented by this abbreviation. So because we have nothing left, we know that this is false and we cannot continue past here. So another case we might have is where our abbreviation actually gives us more characters than our word. So if we follow our logic here, we'd hit this not same case, we would abbreviate this number and say, okay, so now what we need to do is we need to say, we want to move this index up by 2. So what we'd say is we go to index 2 here and we increment this. So you might think that this is a valid case because as we've said before, as long as both the indices are outside of the range, they're both past the word and the abbreviation length, this is valid. But remember, this is actually not valid because we would want our word to end at 0, 1, right? This is the out of bounds for this word. But we're at index 2, so this means that we've actually gone too far. Our abbreviation gives us too many characters, more than are in this word. So in this case, we also have to return false. So another edge case we have to consider is if our abbreviation gives us more characters and we end at a greater index than we actually have as part of our word. So let's hop over into the code and see exactly how this works. So the first thing we do is set up 2 variables that track our indexes. So we have one index pointing to our current position in the word and another pointing to the current position in our abbreviation. So we start this while loop, and what we do here is we continue while the abbreviation index is less than the length of our abbreviation and our word index is less than the length of the word. So while either one, or rather while both are in bounds in the word, we keep going. So the easy case is this else statement down here. So this is what happens when both the characters are the same in the abbreviation and the word. Here we just increment and continue. This is the harder case here. So here we check if the abbreviation and word character are not equal. So what we do is try to parse out a number from the abbreviation. So we go through the abbreviation, and while the character we're looking at in the abbreviation is a digit, what we're going to do is add that digit onto this current number variable and increment our index by 1. So if we have 2 cases we're handling here. So if there is an empty string, right, which is what this is checking for, what that means is that we had 2 different characters, but the abbreviation was not a number. So this is the case where, say, we had an I in our word, but an A in our abbreviation. So that's a mismatch. It's not a number, and we know that we cannot abbreviate this word. The other case is that we do have a number, but our first digit that we've seen is a 0. So we know that we cannot have leading 0, so in this case, it's not a valid abbreviation. So again, if we don't have any number in our abbreviation, or if the number starts with a 0, we just return false. Then what we do here is we say we want to take whatever our word index is currently, and we want to add whatever the current number that we found is to it. And this represents jumping for the number of characters that our abbreviation told us to. So then at the end, this is where we check for those 2 cases. So we want to return false if either the word index does not equal the length of word or the abbreviation does not equal the length of abbreviation. So what this is telling us is if we either haven't gone far enough in our word or we've gone too far, return false. And similarly for abbreviation, if we haven't gone far enough or we've gone too far, then we return false. And remember, we want to end with both with the index right after the end. So say if the length of our word is 10, we want to end at 10 plus 1. if the length of abbreviation is 5, we want to end at 5 plus 1. So we're checking for the exact length here. And if we don't hit any of these cases, we just return true. So let's submit and make sure that this works. And it does. So this was another interesting meta tag problem. It technically isn't easy, but there's just a lot of edge cases you have to consider. It's definitely good to practice these type of questions and be good at them. So hopefully this is helpful and it made sense, and thank you for watching.